All right, welcome everybody. Today we're going to be tackling some more IFR written test, knowledge test, I should say, knowledge test questions. We're kind of doing that same thing I did before with rapid fire, so we're just going to roll through a bunch of questions as fast as possible, get the most as we can, okay? This one's going to be instrument approaches is kind of the focus. So as you can see here, we got an instrument approach plate. I cut the top of it off just so it fit. You don't need it for this question, so just know there's more stuff usually up here on top of the plan view. So the plan view, right, the profile view, we got all the stuff. So this question, what determines the missed approach point on the localizer DME approach at the Portland International Airport? You're going to want to focus on kind of the profile view because we got a localizer here. So the localizer DME, the missed approach point, the MAP, okay, that's going to be determined by the as you're along this course, right, you're trucking along here, which is the last published point on the profile view. The last one. So we get to this last one, right? Last all the way to here, right? That's the last thing. And then see how we're going here and we go one more and then boom, so we're here. So we know that the missed approach point, which is what this question is asking about, right? Where is the missed approach point? The last one, what's the last one on here? IGPO 1.2. Okay, IGPO 1.2. Well, IGPO 1.2 is that. There's your answer. It would be A. Okay, so let's talk about these other ones real quick just so we know. 160-degree radial battleground vortex. Where's that? So that's this guy right here, right? That's this leg, little guy. That's not going to be it because that the only reason this is even on here, this is part of the missed approach procedure. Okay, this whole section is missed approach procedure stuff. That's not part of the approach. If you're using that, that's not even a part of the actual approach. It's part of the missed approach. Okay, so you can think of that as not really something you. Now this one's 6.2 nautical miles from on approach fix. So the final approach fix is right here, and then you're gonna go bump in here, go that way. Uh, that's not how we determine the missed approach point on a localizer. The way we determine a missed approach point on a localizer is what we talked about at the beginning, which is the last point along the profile view. So IGPO 1.2 DME, not just IGPO 2.8, IGPO 4.1, right? These are all certain distances from that, right? But actual IGPO 1.2 DME on your, in this you got to localize your DME, so you have GPS telling you your distance, or you have the actual DME that's going to tell you, hey, I'm 1.2 from IGPO. It's time to go missed approach. I haven't seen the runway yet. Time to go. That's my approach. Cool. All right. All right, on to the next one here. We're going to talk about the ILS localizer runway 6 in a Bradley. Okay, so I cut the top of this off because we don't need it for this. We only need this profile. This is the profile view right here, right? So we only need that. And then I also brought in this table from the terps that you're going to need. You're going to have access to this table. It's one of the legends. This one's legend 27 in your testing supplement. So if you get a question that talks about 90 knots is ground speed, blah, 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 all this stuff about the glide path, make sure to reference this table, okay? Because there's no other way you could come up with these numbers. So if you're sitting there on the test like, where would I get this from? Like, oh, we probably need this table, okay? First off, we're going to talk about this. So this is the profile view. The thing in here that's really important, it says using 90 knots as ground speed along the final approach segment, okay, what rate of descent should be initially to establish the glide path? The key word here is going to be glide path. In order to find the glide path for this, you go up to here where it says GS 3 degrees, okay? GS 3 degrees, so that's your key. So that 3, we're going to then take that 3, we're going to come down here to this table where it says 3, see that? And this table's pretty good. All you're going to do here is you're going to go, okay, I have 90 knots. I was told, to establish 90 knots remember from this one earlier, this one here, okay? So I was told to use 90 knots, so I'm going to follow that straight down to the 3 degrees, and then over from the 3 degrees, and I'm going to get 478. So 478 is going to be as the answer, but again, over here, what do we have? Do we have 478? No, we have 480. So they're going to go ahead and say that's 480, okay? So that's going to be your correct answer for this, 480 per minute, okay? These ones are too far off. For what it's worth, the reason they give you 400 and 555 is those are, if you do 2.5 here and 3.5, 555. They're trying to trip you up. They're trying to did he 3.5? That's 555, and then the 400 is if you use 2.5. So those are where those come from. But yeah, so for this one, don't forget to use the legend, okay? And then don't forget to look for the glide slope degrees on this ILS glide slope. It's got 3 degree. Cool. All right, right on to the next one here. This one is actually maybe one of the easier questions you'll get. It says, what's the LPV decision altitude, okay? It says LPV, and it says decision altitude, okay? And then it gives you three of these, but like, what are we talking about, guys? 1429, right? Just do that one. The only way you'd get tripped up on this one is if you don't read the question very well and you say, okay, what is the decision altitude? And you don't catch this LPV guy right here, and you start to read off the LNAV VNAV mins, and you're like, okay, LNAV VNAV seems right. Maybe I'll do 1563. So just be careful and read this one. This one's pretty easy. Just follow it along. There's no trickery here. 1429 is going to be the minimums MSL for the LPV decision altitude approach. Cool. All right, so here we got a little bit of a, I think a little bit of a more challenging one, I'd say, but still doable. A little bit of a fun one here. So we got the LDA runway 6. Okay, so this is a precision approach. It's asking us how do we identify the missed approach point. Okay, remember earlier we did this with the non-precision. We said non-precision approach. Let's go to the profile view. Let's follow it along to the last point. Where's the last point? ISZK 1.4 DME, right? All right, we found it. Great. So what we can do is if we can take that right out. This is not a localizer DME approach. It's not some non-precision approach. It's a precision approach. So don't do that. Okay? Don't do any of that. What you're going to do for this one is you're going to go ahead and go right to the LDA, glide slope runway 6, assuming you have the glide slope. I don't know why you wouldn't have it. It doesn't say you don't have it, so we're going to assume you do. You're going to be this box here. FA scores this is correct, 16.5. Correct answer. So assume that you have the glide slope. This time expired one, this is for this box down here. You guys see this final approach fixed approach point, 8.3 nautical miles. You can time it. If you're going 90 knots and you hit the final approach fix, which is RAM key, which it says RAM key, 5.5 minutes. Let's say for some reason you lose GPS or something, and long, I don't know, 90 knots, 5.5 minutes, miss approach point, great. But you're not going to use that, assuming everything else is working. So you're not going to use the actual. And this is scored as the correct answer on the test, 1605 MSL. Sweet. All right. So good job so far. Last thing we're going to do is a couple rapid fire, just some rote memorization stuff. Get you ready to take that test, okay? So this first one's going to be a nice one I like to remember. What does the runway visual range value represent when depicted on certain APs, okay? So this is what you want to do. Visual range. See this on your test, okay? I want your brain to go right here. Horizontal, okay? You see that? Those two are linked up. See slant range? Get it? Slant range. Get it? Slant range is not right on this question, okay? So just for actual learning, the horizontal distance a pilot should see when looking down the runway from a aircraft. So how far you can see visibility, right? So if you see an RVR, visibility. All right. Cool. So that one's good. Now the second one, how can a pilot determine that there may be obstacles penetrating the obstacle identification surfaces of the ILS with a Mauser? Okay. So remember, Mauser. And care should be taken in the visual segment of the approach. So care should be taken in the visual segment of the approach anyways, but I guess the FA means more care than usual. Whatever. So we can do this process of elimination, or we can do it with actual knowledge. First, we're going to do process of elimination. So the runway has a VASI, right? So like the runway having a VASI doesn't mean anything. It just has one, right? So our runway's got these approaches and stuff. These things don't relate, right? So this is just kind of a random, that's not it. The approach chart has a visual descent point, or VDP published. So VDP, this is for non-precision approaches, right? Is an ILS a non-precision approach? No. So see that? You should think, okay, that's not right, right? That's not right. So what we're going to do is we're going to think VDP means that doesn't work for this. So then here we go. The post visibility for the ILS is 3/4 such amount. So now you know the answer with that. All right, so if we're going to actually learn this question's trying to tell us, it's that if you see an ILS normally, like an ILS with a Mauser, that's the kind of why I underlined that earlier. Visibility should probably be half. That's terrible. Half a statute mile, okay, normally. This approach has 3/4, right? Because the FAA is saying you should probably be able to see a little bit more at minimum to be able to do this, just in case one of these obstacles gets in the way on your visual. Because remember, we're talking about the visual descent, right? So they're going to add some to this. So when you see a Mauser ILS and you're like 3/4, what the heck? That's not normal. It's because this is probably what's going on. Okay, but now you know the why, and you also know the how to find this answer easy on the test, which is think about those other ones, right? hopefully this helped you guys a little bit. We got those 4 kind of tough questions, kind of with some approach plates and stuff. We got a couple rapid fire here at the end. I wish you the best luck on your test. Thanks for watching. See you later.